Global warming also influences precipitation. The amount of ocean water that evaporates into the atmosphere increases exponentially with temperature. Rising global temperatures thus result in higher humidity, which in turn promotes formation of clouds and precipitation. Indeed, annual precipitation over land increases an average of 2% during the 20th century. Regional variation is high. For example, USA experienced a 7% increase, more than 3 times the global average, whereas sub-Saharan Africa experienced more than 30% decline. Global warming determines the development of major storms. On November 30th, 2006, the Atlantic hurricane season of that year ended without a single hurricane striking the United States. Contrast this with the previous season, the 2005 season, when an unprecedented 15 hurricanes struck the United States, nearly a third of which attained Category 5 status, where winds exceed 280 kilometers per hour or 174 miles per hour. Worldwide, major storms called hurricanes, typhoons, or cyclones, depending on location, numbered less than 60 in 2006, down from an average of about 80. Clearly, the number and severity of storms varies widely from year to year. This underscores that there's multiple factors involved in the development of major storms and how difficult it is to get accurate prediction. The primary source of energy that empowers storms is the condensation of water. When water condenses, that is, when it changes phase from a gas to a liquid, it releases large amounts of energy. The 78 watts per meter squared released annually to the atmosphere through this process exceeds the energy that the atmosphere absorbs from the sun. Conversely, when water evaporates, it removes energy. Most major storms originate in the tropics when water evaporates from the warm sea surface, rises in the atmosphere, and condenses in the relatively cooler, higher altitudes. A major storm siphons vast amounts of water vapor up along the walls of its eye that releases roughly 130 trillion calories per second when it condenses. The majority of this energy generates updrafts that lift storm clouds even higher to cooler parts of the atmosphere, accelerating condensation. Another portion of this energy drives the ferocious winds that rotate in response to the spin of the planet, like water flushing down a toilet. The winds kick up water spray, and along with this low atmospheric pressures near the eye, enhances surface evaporation. This positive feedback, higher updrafts, accelerating condensation, and faster winds and lower pressures, spurs the growth of storms until they pass over land and are cut off from warm surface waters. Global warming, through its effect on sea surface temperatures, should increase the severity of storms. Indeed, several studies have found such a trend whereby the number of cyclonic storms occurring worldwide has not changed, but the percentage of these storms that fall into categories 4 and 5, that is, winds above 210 kilometers per hour, 131 miles per hour, has doubled. Nevertheless, the record-breaking 2005 North Atlantic hurricane season, followed by the 2006 season, or lack thereof, only serves to cloud the relationship between global temperatures and storms, and the controversy still swirls around this issue.